Here's example number 3 for critical numbers. This one is a rational function because it's the ratio of these two polynomials. So we're going to find the critical numbers by determining the derivative and then figuring out where the derivative is 0 or undefined. So this is a quotient rule. So we're going to take the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. We'll simplify the top. I'm going to distribute the 2x. So we have 2x squared plus 2x. And then the second part is minus x squared times 1, which is x squared. Combine the 2x squared minus x squared, you get x squared plus 2x. Since we need to find out where this equals 0, it's going to be easiest to factor it. So the top factors like this factor out in x. Bottom stays x plus 1 squared. So now we need to figure out where this derivative equals 0 or undefined. So we can bring it over here. This derivative is 0 when the top equals 0. So the top is this. So this would equal 0 when x equals 0 and x equals negative 2. But the derivative is undefined when the bottom equals 0 and the bottom equals 0 at x equals negative 1. So now here's the little thing you have to watch out for if you're looking for critical numbers. They are critical where the derivative equals 0 or undefined, but the numbers themselves have to be defined in the original function. So when you get an undefined derivative, just look back at the original function to see if it's defined in the original function. If you see, when you plug in negative 1 here, it's not defined in the original function because it would be a division by 0. So you don't include that as a critical number. Actually, you can identify it immediately as a vertical asymptote. This is where the bottom equals 0 function. So the vertical asymptotes are not considered critical numbers because they don't exist. So again, the answer to this question for critical numbers are just x equals 0, x equals negative 2. We're going to check out the graph. Remember, critical numbers are where the derivative is 0. So you have a horizontal tangent line, which happens here at x equals 0, and here at x equals negative 2. So that makes sense. And you can also see by the graph that it does have a vertical asymptote at x equals negative 1, which is not a critical number. That's it. That's all there is to it. It's pretty simple. Make sure you practice.